ACL stands for Access Control List. Access Control List is a layer 3 security which controls the flow of traffic from one router to another. So as we know, Access Control List is a security topic. It is used for security. It provides layer 3 security by filtering the traffic. It takes a decision based on the access control list, the statements that you configure.
Yeah. How do you get a job? How do you get in there?
Someone's mic is on, please mute. Okay, so it provides layer 3 security, which controls the flow of traffic from one router to another router. Then it is also called packet filtering firewall. Access control lists basically are a type of software firewalls. So you know, firewalls are two types, hardware firewalls and software firewalls. Hardware firewalls are like the devices like routers and switches we have. Similarly, we have firewalls. We have software firewalls, which are, for example, your software firewalls inbuilt in Windows. And access control list is a software firewall, but it is a tool that we configure manually, and it has to be configured using command line interface. So using certain commands, we create statements how we want to filter the traffic. So which traffic is to be permitted, which is to be denied, or which particular host is allowed for which protocol or which service, and which is allowed. So all these filtering can be done using access control list. And that is done based on layer 3, that means based on IP. So using IP information, the source IP, the destination IP, the access control lists take the decision of whether to deny or to permit the traffic. Before configuring access control lists, like the ACL statements, you should know a few rules that are that all deny statements have to be given first if it is a specific statement. So it's not a must. So it actually says that deny statements have to be given first. That means most specific entry. If you want to, let's say, deny a specific host and you want to permit rest all hosts. So the specific entry is to deny that particular host. So you have to put that statement first. And the reason is to put this most specific entry on the top is that access control list always process the entries from top to down in a sequential manner. There should be at least one permit statement, otherwise everything will be denied, because by default access control list denies everything. Whatever is not matched, it denies. So whatever is not there in any statement, it will be denied. So if you want to permit some traffic, you have to give a permit statement. There is an implicit deny. Implicit deny means the default deny for everything that is not matched. It blocks all traffic by default when there is no match, as it is a security tool to block the traffic, to permit the traffic. So the default action is to deny everything. So whatever you want to permit, you have to give a statement for that, what traffic is permitted. You can have one access list per interface per direction only. So on a router, when you configure ACL, per interface, only one access list per direction is allowed. Direction means either inbound or outbound. Means the traffic, whether it is outgoing traffic or incoming traffic. And per interface, only one ACL is permitted. Two access control lists per interface, one inbound, other outbound direction is permitted, but in one direction, only one. It works in a sequential order. That's why we have to put the most specific entry on the top, then go in a flow. Then editing of access control list is not possible. If you have done the access control list statement configurations, you have to be very sure that your statements are in a correct order and the statements are correct, because editing the access control lists is difficult. You have to delete the entire group of ACL and create a new one. Selectively adding or removing access control list statement is not possible. And this is in case of numbered ACL. We have two types of access control lists, named and numbered. In named, you can give a specific name to your ACL group. In numbered, you have to give a number. So in numbered ACL, that is the big problem, that you cannot edit. But in the named ACLs, you can edit. So individual lines can be edited, but in numbered, it is not possible. You have to configure everything again, all these statements. So entire group have to be deleted in that case. Okay. Named ACL. ACLs are identified using names rather than numbers. Names are case sensitive. No limitation of numbers here, so more flexibility is there. Named access list. One main advantage is editing of ACL is possible, whereas in number ACL it is not possible. You have to delete the entire group and configure again. Removing a specific statement from ACL is possible, which is not possible in number. iOS version 11.2 or later allows named ACL. Before that, it will not allow named ACL. It was only numbered ACLs before. Then types of ACLs. There are two types of major categories of the ACL, that's standard and extended. Standard ACLs, if we talk about numbered ACLs, the access list number must be between 1 to 99. That is the range of access list numbers in standard ACL. If you talk about standard named ACL, you can give any names, and named ACL doesn't have any classification. You can use any name, whether it's standard or extended. But in case of numbered ACLs, if you're using standard ACL, the numbers should be from 1 to 99. The main difference between standard and extended ACL is that standard ACL is less flexible. It can only filter based on the source IP. So it looks for the source IP when the packet is arrived, and the router which receives the packet where ACL is configured, it will look for its source IP, and only based on the source IP it will match from its ACL statements and take the decision. Whereas in extended, there is more flexibility. In extended, it takes decision based on source IP, destination IP, source port number, or destination port number. So in extended, what you can do is a specific protocol or a specific service can be blocked or permitted, which cannot be done in standard. In standard, everything for that particular source IP is either blocked or permitted according to the action. Can block a network, host, and subnet only based on IP. Two-way communication is stopped. So whatever source IP is blocked or denied, two-way communication is stopped. Will not even receive or send. All services are blocked. So for that particular source IP, every service, HTTP, FTP, everything will be blocked. And always standard ACL is implemented or applied close to the destination. Standard ACL is matched on the basis of source IP. Yeah, so this is about standard ACL. Next, extended ACL. Extended ACL number lies between 100 to 199, can block a network, host, subnet, and service. One-way communication is stopped. So if it is inbound, then incoming traffic will be stopped. If it's outbound, the outgoing traffic will be stopped. But the other way is permitted. Selected service can be blocked. So you can block either HTTP traffic. So for a particular host, a source host, you can block or permit if you want just a particular service, and rest you want to permit. So you can do that using extended, but in standard you cannot. Everything is blocked or permitted for a source IP. Implemented close to the source. Extended ACL matches on the basis of IP protocol number, source address, destination address, protocol option, UDP or TCP or ICMP type code. Yeah. So there is more flexibility. You can do more with the extended ACL. You can filter based on many other parameters, whereas in its standard, only one, that is source IP address. Then some terminology is used in ACL, that is deny. Deny is used for blocking a network, host, subnet, or service. Omit is used for allowing a network, host, subnet, or service. Source address is the address of the PC from where the request starts, or it can be address of the network or subnet. Destination address is the address of the PC or the network where the request ends. Inbound traffic coming into the interface. Outbound traffic going out of the interface. Protocols are used in access control lists like IP, TCP, UDP, ICMP. Operators are used EQ, which is called equal to. You will see that in the configuration, it will be more clear how we use these operators and codes. NEQ not equal to, it less than, LT less than, GT greater than. Services are HTTP, FTP, Telnet, DHCP, all the services. Then in ACL, wildcard mask is used to match the subnet. For example, we use in OSPF, same way in ACL also we use wildcard. Now, you know what wildcard mask is? It tells the router which addressing bits must match in the address of the access list statement. It's the inverse of the subnet masks. It's also called inverse mask. A bit value of 0 indicates must match. A bit value of 1 indicates ignore. Wildcard mask for a host will be always 0000. If it's a host IP, so the wildcard mask will be 0000 because all the bits have to match. A wildcard mask can be calculated using the formula global subnet mask minus customized subnet mask. Global subnet mask means 255.255.255.0 and customized subnet mask is the subnet mask, which gives you wildcard mask. So this is the example. So 255.255.255.255 minus a customized subnet mask 255.255.255.240 gives you the wildcard mask 0.0.0.50. Okay. Now let's see how ACL is configured. So for that, we'll start with standard ACL. Okay, so this is the topology you have to make. Here you have to configure IPs and then configure some routing protocol so that there is communication. So let's say this is 192.168.1.0/24. 254, which is 200.0.0.0/4. This is 200.1.0/24. Okay. For routing, you have to perform any routing. You can configure EIGRP or OSPF. Let's say here the IGRP is configured. Then check by ping from A to server, B to server, you should be able to ping. After that, we will configure standard ACL. So for standard ACL, first of all, the task is to deny host A to access the network 200 1.1.0. The destination is 200 1.1.0 network and the source is 192.168.1.0. Supposing that this is the private network here, our private network, the source, and this is the destination for which we want to filter the traffic. So we want to filter the traffic that is going out of the network from the source. So we will apply it close to the destination. So that means it will be applied on R1, router 1. So on router 1, outgoing interface we will apply it. Why? Because standard ACL is applied close to the destination. Okay. Now, what we have to do is deny host A to access network 200 1.1.0 and permit rest all hosts. So let's say in the 192.168.1.0 network, there are other hosts also. You want to permit all, but you just only want to deny host A to access 200 1.1.0 network. Okay, let's see how it is configured. So for that, we will go on router 1 configuration mode. First, we have to create the statements to deny host A and to permit rest all. So on router 1, we will configure the statement access list, then configure the access list number. Number is, for standard ACL, the list number is 1 to 99. So it can be any number from 1 to 99 if you're using standard ACL. If you're using extended ACL, then it should be 100 to 199. So 10 I'm using. Access list 10. Then the first entry should be, the most specific entry should be on the top. So deny, then host. If it is a particular host, then you have to type the term host and then give the host IP 192.168.1.1. If you're talking about the entire network, let's say you want to block the entire 192.168.1.0 network, then you don't have to write host, then just simply write access list 10 deny, then the network IP and wildcard mask like this. So supposing that I'm blocking the entire 192.168 network, I will type 192.168.1.0 with wildcard mask 0000255 like this. Yeah. But here I want to block the host A only, so I will write host and host IP 192.168.1.1. This will be the first statement. Second will be the permit statement. If you do not give the second statement, everything else will be denied automatically because that is ACL. What ACL do is deny everything. So access list permit. So I have to tell that permit rest all. So 10 permit. For rest all, I can use term any. So access list 10 deny host 192.168.1.1 and second statement access list 10 permit any. Statements are configured, only two statements are there that is configured. Now you have to go to the interface to apply it. These statements will not work until you apply it on the interface because ACL works only when it is applied on the interface in any direction, either inbound or outbound. So you have to see you are applying it on router 1. Router 1's inbound interfaces 200.0.0.1 and outbound interfaces 201.1.0. Right? So that is seen according to the source and destination. So the source address is 192.168.1.0. So from this network, the traffic is going into this interface and going out of this interface. So this will be the inbound interface, this will be outbound interface. Router 1 is close to the destination. Similarly, router interface, this one, outgoing interface, is close to the destination. So in standard ACL, it is applied close to the destination. So we will apply it here. Suppose this is fast Ethernet 0 by 1. And this is fast Ethernet 0 by 0. So we will apply it on fast Ethernet 0 by 1. Interface fast Ethernet 0 by 1. And here the command will be IP access group. Now you have to group these access list statements that you have created into a group. Number will be the same as you have used 10. Then inbound or outbound. So it is outbound. So write out. If it is inbound, you have to write in. That's it. When this is done, after that, you can verify the statement and the access control list by show access list, or also show IP access list. And now ping. When you ping from A to server, you will not be able to ping. But if you ping from B to server, you will be able to ping because of the access control list. Because this is what we want. We want to deny host A and permit rest all hosts. So B is permitted. Right? So you can start this lab. This is what you have to do. The same topology, make this topology, give these IP addresses, configure some routing protocol. It can be any of your choice, RARE, PSGRP, OSPF. You just have to make connectivity from A and B to the server. You should be able to ping. After doing that, you have to configure ACL and then check. Okay, so you can start the lab now and let me know when it's done. Okay, let's start extended ACL. So in extended ACL, you can filter based on source IP, destination IP, source port number, destination port number, protocol type, or service. Yeah? So more flexibility is there. So suppose in the same lab, what we are doing is, what you can do in the same lab, just remove the access control list that you have applied for standard, or you can start with a new lab also. So in extended ACL, what we are going to do is deny host B to access web. Web means HTTP service via server, the destination server, that is 201.1.1. Permit rest all hosts in that network to access web. Same via server 201.1.1. So in these two statements, we are talking about only the web service, how to treat the web service. So B should be denied to access web and rest all hosts should be able to access web. Now, how to treat other type of traffic? Because in the network, there are many other type of traffic. There is FTP, IP traffic. Yeah? So how to treat all other type of traffic? So rest all traffic must be permitted. I want to permit rest all traffic, only deny host B, and that too to access web service particularly, not everything else. So host B should be able to ping, should be able to access FTP and all other services. Only web should be blocked. Rest all traffic is permitted. So this is what we have to do using extended ACL. Okay, so to do so, the commands are a little different than standard. Standard are pretty simple. In extended, the syntax is what you have to remember. So let's say we are configuring it on router 2. For extended, there is no such rule. It should be placed close to the destination or source. In standard, it must be close to the destination, but in extended, it can be applied according to the scenario. Let's say on R2, I am configuring it. So the command will be access list number 110. Why? Because the access list number for extended ACL is 100 to 199. So from that range, I'm using this one, 110. Then the most specific entry is to deny. Then you have to write TCP or UDP. So I'm writing TCP because I'm talking about the web service, HTTP, which is TCP. Then host and host IP, the sources 192.168.1.2, host B, right? To the destination is host 200.1.1.1. Then write EQ that we discussed, that we use equal to for port number. Port number for HTTP is 80. So this is how we configure extended ACL. This is the syntax of the command. Access list number, deny TCP or UDP, then the host, that is the destination, the source host, and then the destination host, host IP equal to, and port number. Similar way, we will do the next statement. So in the next statement, it will be access list 110 permit. Now, the next statement is to permit REST all to access web. Again, we are just talking about web. So permit TCP. Now, for REST all, instead of host, we are using any, because REST all. And the destination is still the same, host 200.1.1.1, because that is the web server in our case, equal to 8. Yeah. So these two statements says that the host B is denied to access web and rest all are permitted to access web, port number 80. This is how the router will identify the type of service. Then the third statement will be to permit rest all traffic. So to permit rest all traffic, the command will be access list 110 permit. For rest all type of traffic, it can be a mixture of TCP, UDP, ICMP, all traffic. So we use the term IP. IP, any. For any source to any destination, everything else is permitted. So these are the three statements. Now we have to apply it on the interface, like the same we did in standard. So go to the interface, suppose fast connect 0.0 it is. We are applying it outbound. So IP access group 110 out. That's it. After this, just verify by show IP access list or show access list and ping. In this, what will happen when you will ping? You will be able to ping from both the PCs to the server, because ping is allowed, everything else is allowed. Only host B is denied to access web. So how you will check it? Let me show how to verify this thing in Packet Tracer. So in this, what will happen? This is suppose the HTTP server here. Now it's here. And let's say there is a PC. I'm just using one just to show you how you have to check the HTTP. So on this, configure an IP 10.10.10.1. 10.10. And accordingly, 100 is the IP here. Password is Cisco interface fast connect 0 by 1. IP address host and then 100. Okay, I can ping. Okay, that's successful. Now let's check if we can ping from this PC to the server. 82.168.1. Okay. Now I have to check whether I can access web. So to do that, first make sure that your HTTP service is enabled. HTTP here is okay, on. Now from the PC you want to access web, right? So to check it, you have to go to the desktop option, then web browser. In the web browser, in the URL, type the IP address of the server. The IP address of the server is 192.168.1.1 in this topology. In the lab that you're going to do, in that the IP address of the web server is 200.1.1.1. So you have to put that IP address here and enter. And this page will open, Cisco Packet Tracer, welcome to Cisco Packet Tracer. This is default. This means that you are able to access web. So what will happen in your lab, or when you will do this lab, after configuring extended ACL, when you will access the web from host A, this page will open. That means you will be able to access web. But from B, it will give you a request timeout message. Means this is blocked. So this should be the answer. And when you ping, you should be able to ping, but only the web should be locked for host B. Okay, so this is the task you have to do for extended ACL. You can use the same lab that you did for extended by removing the standard ACL command, or you can start with a new lab.